here's another example. We're going to use tables now, and we're going to evaluate f of g of 3 and g of f of 4. Okay, so don't be too intimidated or anything just yet. We'll work through this, and I'll show you how to solve these problems. So let's work on the first one. So we're going to figure out f of g of 3. So again, something to remember. When we have composition of functions, a function inside of another function or anything like that, we're going to work from inside to outside. Okay, so we start on the inside. So this 3 here, what does that mean? So let's look at our tables actually. We're given, okay, so this one is x and f of x, and this other table gives us x and g of x. Okay, so we're given basically two different functions, this f of x and the g of x, and we're basically composing them in the problem. Okay, so we're going to say, okay, so this 3 that we have over here on the right side, this 3 is in place of x. Okay, so x is equal to 3. So when our x is equal to 3, then we can start moving to the outer side, right? So then we know x is equal to 3, and then what is our g? So g of 3, we have to figure that out first, is equal to what? Now we reference our table, okay? So when x is 3, so when x is 3 here, what is our g of 3, or g of x? That would be 2, okay? So the function value, or the value of the function g, evaluated at x equals 3, is equal to 2 according to our table, because that's what we were given, right? So we have this much, and then because we just figured out g of 3 is equal to 2, now in place of this g of 3, we can plug in a 2. Okay, so now we're down to, we reduced this to just a simple problem, f of 2. What is the value of our function f evaluated at the input of 2? Okay, so in this case, it doesn't matter. So if we look at our table, this kind of takes the place of our x, okay? X equals 2. X doesn't equal 3 anymore, okay? Because that was our innermost x, all right? But now our x, in this case, it's kind of weird because they use the same variables, but basically all this is saying is that whatever's inside your parentheses, that's your input value, okay? So when our input for f of x is 2, which is here, so this is kind of like an input-output table, right? So input and output. It's basically all it's saying. So when our input is 2, our f of x gives us out an 8. Okay, so this is going to be f of 2 is equal to 8. And that's going to be the value of, so this is equal to f of g of 3. Okay, so again, we worked inside to outside. So now let's try the other one. We'll do some more practice. So g of f of 4. So this one's backwards, right? Because g is our outer function and f is our inner function now. Well, nonetheless, we start from the inside, so our 4 represents our x on the inside there. That's the very first input to our inner function, okay? So what is f of 4? So we have to figure that out. F of 4 is equal to what? So we find our input on our f table, right? So 4 gives us, when we input 4 into f, that gives us out a 1. So f of 4 is equal to 1. Okay, and then that means we can kind of just replace this f of 4 with a 1 instead, and then we just ignore this x that was before, okay? So now we're at g of 1, okay? And now we just switch over to the other table. We look at, okay, when our input is 1, what does our g function give us? And the answer would be a 3, okay? So in this case, our g of 1, or also, which is equal to g of f of 4, that's going to be equal to a 3 here, okay? So these are our answers for that problem. Okay, so we're going to do something similar on this example, except for now, instead of using tables, we're using graphs that we're given. Okay, so here we're going to evaluate f of g of 1. So again, like we do with composition of functions, we're going to work from inside to outside. So our very first, our initial input is going to be 1, and 1 is being inputted into g. Okay, so when x is equal to 1, what is g? So this, we basically have to figure out what is g of 1. G of 1 is equal to what? And we look at our g of x graph. So when our input, this is like our x-axis, okay? So when our input is 1, the value of our function is, and that would be 3, okay? Because it's at the level of 3. So g of 1 is equal to 3, so we can replace the inside of f with an entire 3 here. Okay, so this turns into f of 3 is equal to what? And now we switch over to our f of x graph. Okay, we look at the input of 3, and then we just go up and find our function value. That would be actually at the top of our u, and this is equal to a 6. Okay, and that would be our answer. This is equal to f of g of 1. Alrighty. Okay, so now we'll go on to a little bit different concept. Well, not really. We're still on the whole topic of composition of functions, but now we're going to do composition using formulas, okay? Because so far we've been doing using tables and graphs and things that were already given, but now we're going to use actual formulas. So still, again, I'll rewrite it here because it's really important. We're going to work from inside to outside. Work from inside to out, okay? Alrighty, so let's say we have something like this. Okay, so this problem tells us given f of t is equal to t squared minus t and h of x is equal to 3x plus 2, evaluate this guy right here, f of h of 1. Okay, so again, don't be scared by this. We're just going to do the same thing, work from inside to out. So the inside would be, okay, this 1 is our initial input. So input is equal to 1. And the first thing we're inputting that thing into, that function would be, the first function, the innermost, would be h, okay? So the first thing we have to do is figure out what is h of 1. And that's pretty easy, right? Because we're given a formula here, right, for h of x. So 1 is in our x spot, so we're just going to plug in a 1 wherever we see an x. So that would be 3 times 1 plus 2, which gives us an output of 5, okay? So now we know, okay, h of 1 is equal to 5. So we can replace this h of 1 on the inside with a 5, okay? So now the problem turns into, okay, what is f of 5 now? Alrighty? So we're going to ignore this initial input, and now our input to our outermost function is a 5. So we're just going to find f of 5, and we do so by looking at the formula given for f of t. So 5 is in the t spot, so we're just going to plug in a 5 everywhere where we see a t. So that would give us 5 squared minus a 5, this is equal to 25 minus 5, okay, and then that just gives us a 20 out, okay, and that's it. We've reached our outermost function and evaluated that, so this is going to be equal to our original f of h of 1, okay, so 20 there. Alright, so another approach, actually, to solving a problem such as this, or any kind of composition of functions problem where you're given formulas, instead of juggling these two formulas, because we had f of t, this thing, and this h of x, and it might be like really confusing because you're like, well, which one do I plug in my input value into first, the f or the x, or the h or the what? So instead of juggling like two formulas in this case, what we can do is express the composition of functions as a single function first, and then we plug in that initial input, which in this case was a 1, okay? So let me show you how to do that. Okay, so here's method number 2. Method 2. What we're going to do is compose, or put together. That's what it means, just kind of stick them together. So compose the functions first, using variables, that is, and then plug in the value you want. Plug in your input value. Okay, so let me say this in terms of like mathematical symbols and everything. So what we're going to do first is find f of h, not of 1, but of variables. So this would be h of x, okay? And we're using x because h goes with x. The input variable, your initial input variable, has to match the one, the innermost function that you're putting it into. So x belonged to h, so we have to put an x there. Okay, so what we're going to do is find this first, and then plug in a 1, and then plug in 1 in this case, because we want to find f of h of 1, right? And then plug in 1 to this function, to this singular or single function, okay? So you might be wondering, okay, well, how do we get to this guy in the beginning? So what we're going to do is look at this. So what this says is basically that h of x, this entire thing that I'm circling, is the input to our function f. Okay, so this, we're going to consider that the input, okay? So we're just going to kind of like, and h of x, we know h of x, they gave us the formula to represent that function is 3x plus 2, right? So what we're going to do is actually plug this in. So f of h of x, we're going to consider h of x our input, okay? And this is going to be equal to what? So if we just stick an h of x into wherever we see a t up here, right? Because t is our input. That's the same thing here. I'll just write it down here so we can see it closer. So f of t is given as t squared minus t, okay? So if now I have an h of x in for the t spot, then that means I have to plug in h of x into wherever I see a t on the right-hand side. So this would give us h of x squared minus an h of x. And notice how when I plugged in the h of x, when I plugged in the input value, I put parentheses around it. And that, for me, I would suggest doing that because it kind of helps avoid confusion or any mistakes with like negative signs or with squared things and stuff like that. Okay? So we can go a step further actually, because right now it's like, well, what's h of x? And we know what h of x is because we're given that h of x is equal to 3x plus 2. So for each of these spots, I'm going to plug in a 3x plus 2, okay? Just because we're already given this equality here that the formula for h of x is this guy there. All right, so let's plug it in. So we have, I'm going to keep those parentheses, so we have 3x plus 2 in parentheses squared, right? And then minus parentheses 3x plus 2. Alrighty? So now all we have to do is just simplify the right-hand side to get an actual formula in terms of a variable for f of h of x, which again is a composition of functions. So if we simplify this, we basically just get 9x squared plus 6x, so plus 12x plus a 4. And then minus, we're going to distribute that negative sign. So minus 3x, my 3's look funny, and then minus a 2, okay? So let's continue this on the next slide. So we have f of h of x is equal to 9x squared, then we got plus 12x, and then minus a 4, and then minus a 3x minus a 2. Sorry, that would be plus a 4. Okay, alright, so let's just simplify this. So we just get 9x squared, and we're going to combine like terms, so we get plus 9x, and then plus a 2, okay? So here it is. We've arrived at our variable kind of like definition or formula for our composition of functions. And see how here we have a single function. We don't have to juggle those two other ones like we did on the previous method, right? So now if we want to find f of h of 1, all we have to do is plug in a 1 for x. X equals 1. So then you just do that on the right-hand side, and that gives us 9 times 1 squared plus 9 times 1 plus 2, which is kind of magically 9 plus 9, which is 18, plus 2, which gives us an output of 20, which is the same value that we got when we used method 1. Okay? So there, I just presented an equally valid method for solving composition of functions, and then you want to evaluate it at a certain point. Okay? Alrighty, so that wraps up our concepts video on composition of functions. I hope that helps, and I'll talk to you in the practice problems video if you want. Don't understand.